So hi, I'm Melanie Drake. I'm a systems developer in JMP Development Operations. Our group provides automated processes that build JMP executables and installers, run automated tests, and perform many other tasks to support JMP research and development. Today, I'm going to talk about how we are collecting information from process logs and using JMP to find problems and monitor the general health of one of these automated processes. So processes can create a lot of data, for example, from instrument readings or measurements from a production line. The data might be written to plain text files or structured text files like XML or JSON or CSV. All of this data provides ample opportunities for finding and fixing problems with that process. However, this data is often written to lots of separate files that are constantly being created and updated. This can make investigation very difficult. I'll be talking about the nightly JSL unit test stream. This process produces many log files every day. We found that it was very hard to track and troubleshoot specific problems with our test streams. We were swimming in data, but using it was very difficult. So what is the JSL unit test stream? It's a suite of JSL regression tests that we run using each day's build of JMP. It runs every night on all versions of JMP that are currently in development, and it runs across a variety of Windows and Macintosh operating systems. Testers use these nightly runs to find errors in JMP so they can be quickly addressed by developers, like Justin and Annie. So if any particular test stream doesn't run successfully for that day, then they don't have those test results. So to be clear, I'll be talking about problems running the test stream itself, not the JMP errors that it produces. So for example, for a few weeks this past summer, we actually had 4 versions of JMP in development at once. This meant we were running 18 test streams every night on a combination of JMP and operating systems. One entire stream can take 8 to 12 hours to run. Furthermore, we split each Windows test stream into 3 streams that run concurrently to allow all Windows test results to finish more quickly. Putting it all together, we were looking at 36 separate console logs every day. This story actually starts in the summer of 2024. We had fewer test stream runs, only about 24 per night, but our test streams had a lot of failures every night. Searching through this many logs was time-consuming and not very fruitful. Trying to find out where and when any particular problem happened so we could begin to diagnose and fix it was nearly impossible. So the solution to managing disparate collections of data is to consolidate it in one place, like a JMP data table. Once in JMP, you can visualize and analyze your data and easily share your findings using JMP Live. In our case, we collected all of these separate logs into 2 JMP data tables, one for Windows and one for Macintosh. We created about a dozen graphs that help track and troubleshoot all of our problems with our test streams. The data and all of the graphs are then published to that internal JMP Live server that lets us easily monitor the health of our unit test processes. So I'm going to outline the general workflow first, and then I'll walk through the script and demonstrate our process. So the first step is to find out where your data is and how to read it into JMP. You might have to read files that are saved out to a disk or a server. You might be downloading them from web pages or even getting them from a database. In our case, each console log is a plain text file that we access through the browser UI from a Jenkins server. Jenkins is an open source, web-based automation server that we use to build and test JMP. We use a lot of different JSL functions, like HTTP request or parse JSON, to retrieve logs and metadata and read it into a JMP data table. Step 2 is to import that data into JMP. You'll need to import log files and probably a lot of additional metadata. You can put each log into a single cell or split it across columns or rows. It depends a great deal on what your data looks like and what kind of analysis you specifically need. In our case, each stream run produces a single log file. We put the log and all the other metadata that goes along with one run into a single row, and each console log is in a single cell. Once you have your data in JMP, you'll need to parse it to find the information you need and make it accessible. Depending on your data source, you might use load text file, parse JSON, or parse XML to access your data. You might use regex, JSL pattern matching, or JSL character functions to extract and transform your logs into usable data. Scripts and formula columns also come in handy. In our case, we used almost all of these options. We used formula columns to transform dates, times, and durations. We used regex and JSL character functions to extract specific information from the logs and placed it into a variety of indicator and multiple response columns that we then use in our graphs. We used a script to perform heavy-duty log parsing for performance reasons. Because our logs are very large, each one contains thousands or even tens of thousands of lines long. I've even seen one occasionally, if something terrible happened, with hundreds of thousands of lines. Once you have all your data in a JMP data table, you can explore your data. JMP provides many graphing and other analysis platforms, and you can use these features to find patterns and errors, discover correlations, and track process problems through time. In our case, we made extensive use of Graph Builder. We use heat maps to see correlations between errors and milestones in our process. We use bar charts, needle plots, scatter plots to track errors across time, JMP versions, and operating system versions. We use stacked bar charts and other heat maps to see stream status and missing stream runs. The final step is to share your graphs and conclusions with your team members and your managers. You'll want to present results to specific audiences and share your graphs for visibility, transparency, and collaboration. You might also need to hide private, personal, or confidential data depending on your audience. In our case, we publish a subset of our data and all of our graphs to JMP Live. We publish only the data that's needed for the graphs. Once it's published, it's very easy to discuss the current status and new or recurring stream problems in meetings, and anyone can monitor the general health of our processes with a quick glance. So column tags, a new data table feature in JMP 19, have been very useful for this project. We used 3 column tags to track timestamps for our milestones in the log, to track errors printed to the log, and to tag the columns that we use for graphs. So why did we find column tags so useful? For one thing, it improves JSL coding. We can refer to all columns that have a specific tag instead of having to refer to each column by its specific name. The JSL is much more concise, it's easier to read, and when we update, add, or remove columns, there's no need to update the script. We just need to apply the appropriate tags to those columns. So for example, because we have a tag for those columns that are used in graphs, it's a very easy subset operation to ensure that we publish only necessary data. So now we'll bring up the script and I'll walk through some of the JSL. So to start out, let me clear this out a little. The first thing we do is just to set everything up so that we can run our script. So we include a few other scripts that contain function and variable definitions. We define the path to where our main data tables are located. And we open a CSV file that has important configuration information. So this table contains information on each unit test stream name and which table all the data goes into. Once we have all this, we can start processing. Our main loop goes through this CSV file and processes each row, which corresponds to a single unit test stream. Each test stream is a separate project in Jenkins, and each run of a test stream is a subpage of that main page. So we're going to look at this first row, jump 19 on Sonoma. So I'll set my iteration variable to 1, and we'll get our important information from that configuration file, if it runs, there. And then we can start using HTTP request to query all of the information from that main Jenkins page. What that's going to give us is a list of build IDs for each run for that test stream. The request comes back as JSON, which we then parse in a private function that we've written, and we end up with a list that looks like this. It's just a list of the build ID for every single stream run for this particular stream. However, we already have most of this information in our data tables because this runs every day. We don't want to waste a lot of time processing data that we already have. So we'll open the main data table and we'll get the IDs for all of the runs in this table that we already have, the ones that match jump 19 on Sonoma. I turn both of those lists of IDs into associative arrays, which lets me subtract the runs that we have from the full list of run IDs. And associative array math gives us a list of just the 3 runs that we haven't collected so far. So now that we know what the data is that we need to bring in, we're going to run a private function that runs through each one of these and gets all of the metadata and places it into a new table. So I'll open a representative table here. The metadata that we collect includes the duration of our test stream runs, the name of the run, the ID for each one, whether it succeeded or failed, when it ran, and most important, the URL for that console log. Once we have that information, we can create a new column to hold those console logs. And then it's just a matter of using load text file for each URL to bring in the console logs. You can see these logs right here. All of the information is in just a single cell. So now that we've got all this data, it's time to parse it. We'll take that duration and we'll turn it into minutes so we understand it better. And we'll add a date column that takes just the dates because that's mostly what we use in our graphs. For curiosity, we also add a day of the week. Every once in a while, which day a run is on actually makes a difference. So now that we have all of our metadata in place, we now want to set the stage for parsing the log itself. So again, we track certain milestones in those logs. As a run goes through and it reaches each milestone, it prints the start time into the log. So we collect all of them. So in one of those included functions, we add all of the columns for those milestones, and we also tag them so that they're all together. That function adds a couple of different tags, and they match tags that we use on our main table. Once we have all of those start times, something that we want to collect is the last milestone that started successfully. This can provide a very useful hint for where in our process something might have failed. If the process loses its connection, sometimes the internet drops out or any other number of problems, we get a Java disconnect error, so we definitely collect those. And finally, there's a collection of specific errors in the log that we look for. As we run this script, we'll collect all of those errors, add each one as a column in this table, and in the end, we'll collect all of the errors that we found for each row in a multiple response column, which we then use in some heat maps. So now that all these columns are set up, we can start to parse these giant console logs. The first thing we do is take that single cell, which is one gigantic string, and break it up so that it's a list of strings where each string is a single line of the log. Then we can just loop through that list of strings and look for all of the items that we want to look for. So the first thing we look for are those Java errors. If we find one, we can add it to our table and then move on, because once we hit a Java error, there's nothing else in the log. The next thing we look for are those errors that are labeled as text finders. They all occur at the end of the table, so once we find the first one, we just collect the rest of that console log and again move on, and I'll come back to that in a minute. The final thing we look for is all those milestones. So we collect each one, get the timestamp that's in the log, and add it to our table here. Once we've gone through one entire console log, we'll add all those text finders as indicator columns with a 1 for if the error is found and a 0 if it's not found. And then we collect all of the errors that we found into that multiple response column, and we collect the last milestone that started successfully. So since these console logs are actually in my table, I can run this portion of the loop, and you can see how quickly it goes through all of these console logs. And now we're done. So you can see we've got all of our date timestamps. All of these runs were successful, so there's no Java disconnects, there's no errors. You can see all of these errors have been added. Each error is a column name, they're tagged, and they all have 0 in them. So that's really boring. So I edited this column, or this table, and I made some failures. I labeled 2 as failures. I deleted a couple of milestones, which now changes our last thing started column. And I made a few of these indicators for errors as 1, so our multiple response column now has a few errors in it. So that's everything for one test stream. This loop will continue, and it will take care of the next row and the next row. As we do each one, it'll concatenate our new rows into our main data table, so you can see these 3 that we've just added. So in the end, at the very end of the entire loop, we've collected all of our new data into our table. And this loop is the main meat of the process, and it took us a long time to develop. We all worked together to figure out exactly what information we needed, how best to collect it, and what graphs were best to show the data. So once we have all this data, the next thing we want to do is graph it. You can see we've got a lot of graphs saved to this table, and I'll show you just a couple of them. So there's one that shows duration by date and operating system. A big takeaway here is that unit test stream runs that take a very short amount of time or a very long amount of time are problematic. There's going to be failures there, and we want to investigate them. Another one shows correlations between Java errors and those milestones. Sometimes this can tell us that we need to address something in our script, optimize it in some way, or just reduce the risk of disconnects. My favorite script is one I look at every morning, and it's a heat map showing our build status. So the first thing you can see is that we don't run these on the weekend because we take weekends off. It's very easy to see which ones were successes, which ones were failures. You can see areas where this unit test stream didn't run at all. We probably had a machine configuration problem, and it probably took us apparently a couple of weeks to fix. Finally, you can see these 3 runs that I just added. As this is updated every day, this gets filled in and it continues marching to the right. So now that we've got all these really cool graphs, we want to share them. So we publish them all to Jump Live. So to do that, the first thing we do is make a connection to Jump Live, and these connections are defined in File, Publish, Manage Connections. So we open our big table, and the first thing we do is run a subset script. So first of all, why are we running a subset script? So you'll notice our main table has 39 columns, and one of those columns contains gigantic console logs, which aren't used in our graphs at all. These 9 columns are the only ones that contribute to the graphs, so those are the only columns we're going to publish to Jump Live. So once we have our connection and where we're going to publish it to, we send it all to a private function that updates the published data in Jump Live, and then it loops through each one of our graphs, runs it, updates that graph in Jump Live, and then that usually only takes a few minutes to run through everything. And then, once it's published, this is what our dashboard looks like. Again, it's very easy to take a quick look here and see if there's any particular graph we want to open. So here's our duration graph again. All of our graphs have local data filters that let us drill down into specific streams or filter by time. Here's one where I filtered out 19 Monterey because we stopped running it after a while. Oh, I did it right. I never know which button to push. So in the end, what did we accomplish? So we automated our insight. All we have to do is look at these graphs every morning to see what's going on with our processes. The whole thing is self-updating. We don't have to micromanage any specific errors. It's all self-publishing. Everything is predefined, and it runs and publishes itself every day. So as we worked through all of this data, we made decisions on what we needed to track. We changed what we printed to the console logs, like adding those start times for milestones. We decided what graphs worked best to show the problems to solve. And by the time we had this script finished and running, we'd also solved all the problems we'd been struggling with. So our graphs are usually green most of the time because the test streams usually run. And when something bad happens, it stands out immediately. We see it, and we can easily investigate it. So I hope I've inspired you to start analyzing your process logs and solving your problems. Thank you.